You think you remember things exactly as they happened, but neuroscientist Daniel Shatter proved your memories are reconstructed, not replayed, every single time you recall them. That means every memory you trust could be subtly different from the original event. So why does your brain do this, and what does it mean for everything you think you know? Fact 1: The misinformation effect. Cognitive psychologist Elizabeth Loftus discovered in the 1970s that false information introduced after an event can actually alter your memory of what happened. If someone casually mentions a detail you didn't see, your brain integrates it as if you witnessed it yourself. This happens because memory isn't locked in, it's fluid and updated every time you recall it. Understanding this explains why eyewitness testimony can be unreliable and why you should be careful about the suggestions people plant in your mind after experiences. Fact 2: Spacing effect. When you spread your learning over days or weeks instead of cramming it all in one night, your brain locks information in way deeper, a principle discovered by psychologist Hermann Ebbinghaus in the 1880s. Each time you revisit material after a gap, your brain has to work harder to retrieve it, which strengthens the neural pathways. The longer you wait before reviewing, without forgetting completely, the stronger the memory becomes. This is why your all-nighter studying strategy basically wastes your time compared to reviewing notes weekly. Fact 3: The serial position effect. Memory researcher Norman Murdoch documented that you remember the first and last items in a list way better than the middle ones, a quirk called the serial position effect. The first items get primacy, your brain focus is fresh, and the last get recency, they're still in your short-term buffer. Everything in the middle? Your brain basically ignores it. This is why introductions and conclusions feel sticky, and why you blank on the middle chapters of books. Knowing this helps you strategically review the material your brain naturally forgets. Fact 4: State-dependent memory. Neuroscientist Daniel Shatter identified that you retrieve memories best when you're in the same mental or physical state you were in when you learned them. If you study while anxious, you'll recall it better when anxious. If you learn while caffeinated, you'll remember it sharper when caffeinated. This happens because your brain encodes not just what you learned, but the neurochemical context around it. This explains why test anxiety can blank your mind even though you studied. Your brain learned it in calm mode but needs to retrieve it in panic mode. Fact 5: The testing effect. Cognitive psychologist Henry Roediger and colleagues proved that taking a test on material strengthens memory far more than rereading or restudying the same material. Even better, the test doesn't have to be graded or correct. The act of retrieving information reorganizes your neural networks and embeds it deeper. This effect is so powerful that it sometimes outweighs studying time itself. If you're preparing for anything important, your time is better spent quizzing yourself than passively reviewing notes. Fact 6: Encoding specificity principle. Pioneered by psychologists Tulving and Thompson, this principle states that memory is triggered most effectively by cues that match the context in which you originally encoded the information. If you learn vocabulary while walking, you'll recall it better while walking. If you memorize facts with background music, that music becomes a retrieval cue. Your brain doesn't just store isolated facts, it weaves them into a rich sensory and contextual web. This is why changing your study location or removing background noise can sometimes make information feel like it disappeared, even though it's still there. Fact 7: The curse of knowledge. Cognitive scientists Justin Kruger and David Dunning, who later became famous for the Dunning-Kruger effect, identified this trap. Once you understand something, you can't remember what it felt like not to understand it. You overestimate how obvious the concept is to someone learning it fresh. This is why experts are often terrible teachers. Their brains have automated the skill so deeply that the learning steps become invisible. Being aware of this curse helps you explain things better to others and stay patient with your own learning struggles. Fact 8: Consolidation and sleep. Sleep researcher William Dement and neuroscientist Matthew Walker demonstrated that memories aren't permanently stored during learning, they're fragile until sleep consolidates them, moving information from short-term to long-term storage. Without sleep, your brain can't lock in what you learned, and the neural connections fade. Deep sleep and REM stages are crucial for different memory types. Deep sleep solidifies facts, REM strengthens emotional and procedural memories. Pulling an all-nighter before a test doesn't just tire you, it prevents your brain from finalizing any learning from the night before. Fact 9: Interference theory. Learning psychologist John Underwood discovered that new learning can overwrite or interfere with old memories, especially if they're similar. When you cram multiple languages, math formulas, or historical dates in succession, earlier material gets crowded out by later material, called retroactive interference. The reverse happens too. Old knowledge can block new learning, proactive interference. This is why learning Spanish becomes harder if you already speak French, similar patterns compete, and why your brain struggles with lists of similar items. Spacing out similar material and using distinct memory cues helps prevent this interference. Fact 10, the generation effect. Psychologist Colin MacLeod found that information you generate yourself, like writing notes in your own words or solving a problem, sticks in memory far better than information you passively read. Your brain treats self-generated knowledge as more important and encodes it more deeply. This effect is so strong that even wrong answers you generate yourself create stickier memories than correct answers given to you. This is why active learning strategies, writing summaries, teaching others, creating flashcards, demolish passive highlight and read approaches, and why this knowledge should reshape how you study for anything. Your brain's memory system is way stranger than you thought, and now you know how to hack it. Which of these 10 facts made you rethink how you learn? Drop a comment below with the one that hit hardest, and if you're ready to learn smarter, hit subscribe for more science that actually changes how you think. BrainBoda out.